Hello and welcome guys to my YouTube channel. In this video, we will be talking about appreciation and depreciation. Now, those terms are used to describe how the value of something changes over time. Okay? Now, for appreciation, let's say you bought a house for $100,000. All right? And a few years later, the value of the house went up to $120,000. So we would say that the house appreciated. Okay, and this is what appreciation is. Now, depreciation, on the other hand, is, let's say you bought a car for $20,000 and a few years later, the value of the car is now $12,000. So you would say that the car depreciated in value. Okay, so you can think of appreciation as the value increasing and depreciation as the value decreasing. Okay. Now there is a rule that we can use to find to solve for appreciation and depreciation problems, and this is the rule. As you can notice, it's very similar to the compound interest rules, almost the same. So firstly, we've got the current, right, which is the current value of the item or the object, and this right here is the original value of the object is equal to, multiplied by 1 plus or minus r over 100 power of n, where r is the rate of appreciation or depreciation, and n is the time, mostly in years, right? Now, as you can see here, the rule has a plus and a minus. So we're going to use a plus when we're dealing with appreciation and a minus when we're dealing with depreciation. Let's take a look at some examples. So John buys a painting for $1,000. The value of the painting appreciates by 5% every year. Okay, what will be the value of the painting after 3 years? So this right here, the $1,000, this is the original value, okay? And this right here is the appreciation rate, which is 5. Now we're being asked about the value of the painting after 3 years. So this right here is n. And what I want to know is the value of the painting, basically the current value. Okay. So for part A, we're going to go ahead and write the rule. So we have C, which is current, is equal to O, original, multiplied by 1. And right here, we're going to put a plus because this is an appreciation scenario. And R is r over 100 power n. All right, now we're gonna substitute our variables. So we have the current value, which is unknown, is equal to the original value, 1000, multiplied by 1 plus 5 over 100 to the power of 3. And now you can just go ahead and plug those numbers on your calculator, and you should get that the current value of the painting is 1,157.6, right? Now, we're gonna round this to 3 significant figures, so 1,160. This is the answer of A to 3 significant figures. Always remember, you always round your answers to 3 significant figures, unless stated otherwise. Now, how much did the painting appreciate? So now we're being asked by how much did the painting appreciate. So we know that the original price of the painting was 1,000, and we know that the new current price of the painting is 1,160. So by how much did the painting appreciate? You would find that by subtracting. So you subtract 1,000 from 1,160 and you get 160. Okay, so the painting appreciated by $160. I hope this was clear. Moving on. Now, let's take a look here. So Emma buys a car for $20,000. The value of the car depreciates by 10% every year. What will be the new value of the car after 4 years? Okay, so again, this 20,000 right here, this is the original price of the car, and we know that it's depreciating, so we're going to use a minus in our rule, and this right here is the rate of depreciation being 10. Now, what will be the new value of the car after 4 years? This right here, n is equal to 4, and I want the current or new value, okay? So we're going to use the rule again. So current value is equal to the original multiplied by 1 minus r over 100 to the power of n. And we're going to go ahead and substitute our variable. So c is equal to 20,000 to the power of 4. And now we're just going to substitute this expression on our calculator. We get current values equal to 13,122. Right, so this is the value of the car after 4 years. As we can see, it obviously depreciated in value. It was 20,000 and now it's 13,122. Part B. But I forgot. Let's round this to 3 significant figures. So this will be 131. Sorry, $13,100. Okay, part B. So how much money value did the car lose? So we don't know how much money value did the car lose. So again, we know that the original value of the car is 20,000 and the new value or the current value is 13,100, okay? So to find how much value or like money value did the car lose, we would subtract those two numbers. So 20,000 minus 13,100, and this gives you 6,900, okay? So this is how much money value the car lost. Okay, moving on. Okay, so a car was bought for $25,000. It depreciates by 8% per year. How many years will it take for the car's value to drop below $15,000? Okay, so the original value of the car is 25,000. And we know that it's depreciating by 8% per year. So this is the rate of depreciation right here. Now, how many years will it take for the car value to drop below 15,000? So this is the current value, okay? So current is equal to original multiplied by 1, and we're using a minus because this is depreciation to the power of n, okay? Now, here's the thing. So we want the value of the car to drop below 15,000. So the way we're going to solve this is firstly, let's see how many years will it take it to drop to 15,000, and then see basically the year after it. So 1 minus 8 over 100 to the power of n. Now, this is very similar to the kind of problems that we used to deal with compound interest, where we didn't know the power, okay? And if you remember, back then we used to solve this by trial and error. So we would start substituting n and checking what value does it give us. So we're going to go ahead and plug on our calculator 25,000 multiplied by 1 minus 8 over 100 to the power of 1. We're going to try n is equal to 1 at first. Now, when n is equal to 1, we get 23,000. Now, what that means is that after 1 year, the value of the car went down to 23,000. Okay? Now, we want the value of the car to drop below 15,000. So I'm going to go ahead and try n is equal to 3. When n is equal to 3, we get 19,467.2. We're getting there. So now I'm going to try n is equal to 5. So when n is equal to 5, we get 16,477 with a bunch of decimals. Doesn't matter. So let's try n is equal to 6. Plugging in n is equal to 6 will give you 15,159. So, okay, so definitely it's right after it. So it's going to be n is equal to 7 for sure. So you go ahead and plug n is equal to 7 on the calculator, and we get 13,946. So how many years will it take for the car's value to drop below 15,000? It's right here at exactly n is equal to 7. So it would take 7 years. Okay. At 6 years, it will be just above 15,000 by like $159. Hopefully, this makes sense. Okay, let's take a look at this example. John buys a painting for an unknown amount of money. Okay. After 3 years, the painting is worth 1,331. So this basically is the current value of the painting. The painting appreciated at a constant rate each year. Given that the appreciation rate was 10%, so this is right here is R, and we are dealing with appreciation, right? What was the original value of the painting? So we want to find O. So again, we're going to use the rule. So the current value is equal to the original value multiplied by 1. And we're going to use a plus right here because this is appreciation. The power of R over 100 power of N. Now, so we know that, firstly, this right here, after 3 years, this is N. Okay? So now, so we know the current value, which is 1,331, is equal to the original value, which is unknown, multiplied by 1, plus R, which is 10, over 100, all to the power of 3, right? And what you can do now is simply plug this whole expression on your calculator, and this should give you can write it as an accurate decimal, 1.331. And now we're going to divide through by 1.331. Now on the left-hand side, they cancels out. And on the right-hand side, you plug it on the calculator and we get that the original value of the painting was $1,000. Okay, let's take a look here. 4 years ago, Joan purchased a car for $15,000. Today, the car depreciated to the current value of 12,150. What is the annual depreciation rate? So we want to find R, okay? Now, this right here, so we know that 4 years ago he purchased the car for this price. So this is the original price, and the current value of the car is 12,150. This is the current value. Now, the car went from 15,000 to 12,000, right, in 4 years. So N is equal to 4. This is how long it took the car to depreciate to this value. So now we're being asked for the annual depreciation rule, rate. And so we're going to use the rule. So Current is equal to original multiplied by 1 minus R over 100 to the power of n. And the current value is 12,150. And the original is 15,000 to the power multiplied by 1 minus R over 100 to the power of 4. Now, the first thing to do in order to solve this algebraic equation is by getting rid of the 15,000 right here. So we divide by 15,000, gets cancels out. Now on the left-hand side, we're going to plug in our fraction to get a fully simplified form, but you need to keep it accurate, of course. It must stay accurate till the very last step. So 81 over 100, okay? Or 0.81, you can write it as 0.81, there's no problem. Is equal to 1 minus R over 100 to the power of 4. Now, again, we want to eventually find the R. So firstly, we need to get rid of this bracket and this power right here. So to get rid of the power, we're going to take a fourth root. So taking a fourth root for the fraction. So on the calculator, you're going to get like 0.9486 and a bunch of more decimal. You don't need to write the whole thing, but keep it accurate on your calculator. You'll use it accurately, but you don't need to write the whole thing. Now, on the right-hand side, this root is cancelled out with the power, so we're left with 1 minus R over 100. So there's different ways you can do this. What I'm going to do is that I'm going to add R over 100 to both sides. And I'm also going to subtract the 0.9486. So it's basically like this R goes to this side and this 0.9486 goes to the other side. So on the left-hand side, we have R over 100 now, and it's positive. And on the right-hand side, we have 1 minus 0.9486. Now you can plug that on the calculator and use the accurate value for the 0.9486. So we get R over 100 is equal to 0.05131. And now we're going to multiply by 100 to find R. And we get that R is equal to 5.131. Okay. Now don't forget that this is a rate, so we give it as a percentage. And since the question did not state any particular unit of round, we're going to round it to 3 significant figures. So this will be 5.13%. This is the final answer. All right, let's take a look here. You invested $2,000 in a piece of artwork over N years. The artwork appreciated by $800. The annual appreciation was 9%. Find the value of N to the nearest year. Okay, so firstly, this was the original amount I've invested into the artwork, basically. So this is the original. And we know that over N years, where N is unknown, the artwork appreciated by $800, okay? So you need to be careful. This isn't the new price of the artwork, or the current price. This is how much the artwork appreciated by. Okay, so you can think of the word appreciated as increased, right? So this is how much the artwork increased by. So it increased by 800. So if I want to know the current value, it would be 2000, which was the original, plus 800, which is the amount that it appreciated by or increased by. So it's 2,800. And the rate is R is equal to 9. and the original is 2000. So we can go ahead and write out the rules. So current is equal to original multiplied by 1 plus, because this is an appreciation scenario, to the power of n. All right. Now we know the current price being 2,800 and the original is 2,000, and 1 plus 9 over 100 to the power of n. So now we want to know how many years did it take for the artwork to reach 2,800 or just exceed it. So again, so the n is unknown right here. So what we're going to do is that we're going to use trial and error to find n. So firstly, I'm going to plug in the expression on the calculator, the right-hand side. And we're going to start with n is equal to 1. And when n is equal to 1, we get 2,180, which is still below 2,800. So now I'm going to take a double step, and I'm just going to go to n is equal to 3. If you plug in n is equal to 3, it will give you 2,590. Now I'm going to plug in n is equal to 4. Okay, so when n is equal to 4, the value of the painting is 2,823. So basically, during the 4th year, the value of the painting reached 2,800, and at the end of the 4th year, it is 2,823. So how many years did it take? It took 4 years. Moving on. A car's value depreciated by 6,400 over 4 years at a constant annual depreciation rate of 8%. What were the original price and the final price of the car after 4 years? So we have two unknowns here. We don't know the original price or the final, but what we do know is that the car depreciated by 6,400. So this isn't the final or the current price of the car. This is how much it depreciated by. Okay. Now here's what we do know. We know that n is equal to 4, and we know that r is equal to 8. Okay. So I'm going to go ahead and write the rule. So current is equal to original multiplied by 1 and minus, because this is the depreciation scenario, minus r over 100 to the power of n. Okay. So again, so current is equal to original. We don't know the current or the original, but we do know the rate, which is 1 minus 8 over 100 to the power of 4. Okay. Now, the way to solve this is that, yes, I don't know the current or the original, and I definitely can't solve this algebraic equation, with the two unknowns. Okay. So we need to express one of the unknown in terms of the other. So here's the thing. So we do know the current price is basically going to be the original price minus 6,400, because I know that the car's value decreased by 6,400. Okay. So like, let's say the original value was X. The current value will be X minus 6,400, right? I hope this makes sense. So what I can do is go ahead and replace this C by the original minus 6,400. That would be the current value, is equal to the original value multiplied by 1 minus 8 over 100 to the power of 4. And now I have an algebraic equation with only one unknown, so I can solve it easily. So the way we're going to do this is firstly evaluate this term right here. So we're going to plug in our calculator. 1 minus 8 over 100 all to the power of 4. We're going to get 0.716 original. Okay. Is equal to the original minus 6,400. Okay. Now we need to collect the like terms. So we have O right here and O right here. So we're going to subtract 0.716. Of course, this needs to stay accurate on your calculator. There's a bunch of more decimal right here. It needs to stay accurate. While also doing that, we will take 6,400 to the other side by adding 6,400 to both sides. So what we're going to get is firstly original minus 0.716 is equal to 6,400. Okay. Now, the way to evaluate this is to simply go on the calculator and type 1 minus your answer, where the answer should be the accurate version of 716 with a bunch of decimal. This should give you 0.2836 original is equal to 6,400, and now we're going to divide by 0.2836 and divide by 0.2836. And again, use the accurate version. Like we said, always use the accurate until the last step. That's when you round. And so we get the original is 22,566.4. And there's a bunch of more decimals, but the question never specified a unit of round, so we're going to round this to 3 significant figures. This is the first, this is the second, and this is the third significant. We have a 6 on the right, so this will become 6, and those cancels out to 0, so we get 22600. So $22,600. This was the original amount, the original price of the car. Okay. Now don't forget, the question still asked for the final price of the car. Okay. So there's no space. I'm going to delete this part right here. Make space right here. All right. So now here's the thing. The final price of the car is basically, like we said, the original minus the depreciation that happened. Okay. Now be careful. So the final price is equal to, don't substitute the original as 22,600 because we're still within the same question. So we need to use the accurate original, okay, which is this one right here, and it should be in your calculator as ans, the previous answer. It should still be there on your calculator. So we're gonna go ahead and write 22,566.4 minus 6,400, and we get that the final price is 16,166.4. We're going to round this to 3 significant figures. So this is the first significant, second significant, this is the third. So we have a 6 on the right, so this will become 2. And those cancels out to zeros. So 16,200. This is the final price of the car, and this was the original price. I hope this was understood. Okay, now let's take a look at some exercises. So as per usual for exercises, you should stop the video and try to solve it on your own first, and then check the solution. Okay, question 1. You invest $3,500 in a rare coin. The coin appreciates by 7% each year. What will be its value after 3 years? So this is the original amount you've invested. And the appreciation rate is by 7% every year. So R is equal to 7. And the value, you want the value after 3 years. So you want basically the current or the new value, which is after 3 years. So N is equal to 3. Okay, so this is straightforward. We're just going to write out the rule. And again, we use the plus right here because this is appreciation. So the current is equal to 3,500 multiplied by 1 plus 7 over 100 to the power of 3. 3,500. And we're just going to go ahead and plug this on the calculator. So we get that the current value is 4,287.6505. And the question didn't state any unit of round, so we're going to round this to 3 significant figures. First significant, second significant, and this is the third. And there's a 7 on the right, so this will become 9, and this will change to 0. So 4,290. Question 2. A laptop is currently worth $800 after depreciating at a rate of 12% per year for 2 years. What was the original price of the laptop? So this is the current price, and the rate of depreciation is R is equal to 12, and N is 2 years. So what was the original price? So we want to know the original, and we're just going to go ahead and write out the rule. We're using a minus because this is a depreciation scenario. And so the current price, which is 800, is equal to the original price multiplied by 1 minus 12 over 100 to the power of 2. Okay? So now what we're going to do is evaluate this entire expression on the calculator. So I'm going to go ahead and plug 1 minus 12 over 100 to the power of 2. So we get an accurate, you can write it as a fraction or a decimal, it doesn't matter. I'm going to write it as decimal, so it's 0.7744. This is the accurate, equal to 800, and now we're going to divide through by 0.744. And we get that the original value is equal to 1033.05, and there's a bunch of more decimals, and we're just going to round this to 3 significant figures. So to 3 significant figures, this is the first, this is the second, this is the third. We have a 3 here, so this will stay as 3, and this will become 0. So it's 1030. This is the final answer. Okay, let me just erase this. All right. Question 3. A piece of land was purchased for 50,000, and after 6 years, it is worth 75,000. What is the annual appreciation rate? So this was the original value when we purchased it, and N is equal to 6 because 6 years passed, and now the new or the current value is $75,000. So we're being asked what is the annual appreciation rate, so we want to know R. And by the way, we don't need the word appreciation right here to know that this is appreciation, because the original price was 50,000 and then it went up to 75,000. So it's fairly obvious that this is appreciation. So the question, if the question does not mention the word appreciation, that doesn't mean that we don't know. We can tell from the numbers. So we're going to go ahead and write out the rule. Current is equal to original multiplied by 1 minus, plus R over 100 to the power of N. And we're going to substitute our variables. So we have $75,000 equal to 50,000 multiplied by 1 plus r over 100 to the power of 6. Okay, so the first step to do here is to get rid of the 50,000. So we're gonna divide through both sides by 50,000. So those three zeros will cancel out. If you plug the thing on your calculator, it will simplify to 3 over 2 is equal to 1 plus r over 100 to the power of 6. And now we want to get rid of the power of 6, so we're going to take root with a base of 6. So on the right-hand side, it will just simply cancel out, and we get left with 1 plus r over 100. On the left-hand side, we're going to get 1.069 and a bunch of more decimals. But as I've stated previously, you need to keep this accurate so it stays as the answer. So now we're going to subtract 1 from both sides. So on my calculator, I will subtract 1 from the accurate answer, and we get a 0.06991 and a bunch of more decimals is equal to r over 100. And now I will multiply by 100, and let's take it over here. So I will get that r is equal to, again, we multiply the accurate by 100, and we get 6.9913 and a bunch of more decimals, but I want my answer to 3 significance figures. So this is the first, this is the second, this is the third, and the 9 doesn't get rounded up. So the final answer is 6.99%. Okay, so moving on to the next exercise. So a piece of equipment is currently worth $9,000, has depreciated over 3 years. If the depreciation amount was $3,000, what is the annual depreciation rate? Okay, so we know that the current price of the equipment is 9,000, and this was the result of the depreciation over n is equal to 3 years. Okay, now we know that the depreciation amount was 3,000, so our equipment depreciated by exactly $3,000. So now we're being asked what is the annual depreciation rate. Okay, so again, so we know the current is 9,000, and that n is equal to 3. All right, and we want to know what r is, but we must not forget this information right here. So we know that the amount of depreciation was 3,000. We can use this information to find the original value of the equipment. So if the new value is 9,000 and it depreciated by 3,000, so the original would be 9,000 plus 3,000. This will give you 12,000. Okay. So again, the reason we added is because we had an original value and we had a new value or a current, all right? And the current value was 9,000, okay? And the way we had this 9,000 is because our original value was had 3,000 subtracted from it, okay? Had 3,000, this is how we got to the 9,000 because we're dealing with depreciation. So in order for us to find the original value, we would add 3,000 to our 9,000. All right, so now moving on, so we're going to write out the rule. C is equal to O multiplied by 1 minus R over 100 to the power of N. And the current value is 9,000. The original value is 12,000 and 1 minus r is unknown. We want to find r to the power of 3. Okay, so how would we solve this? First thing, we're going to divide by 12,000. So the zeros would basically cancel out right here. So we have 3 zeros, and 9 divided by 12 simplified will be 3 over 4 is equal to 1 minus r over 100 to the power of 3. Now, to get rid of the power of 3, we're gonna take a cube root, and I'm gonna take a cube root on the calculator. So on the right-hand side, we are left with 1 minus r over 100. On the left-hand side, we have 0.9085 and so on. Don't forget to keep this accurate on your calculator. Now what I'm going to do is I'm going to move r over 100 over to this side by adding it. And I'm gonna move the 0.9 to this side by subtracting it. So we're going to get r over 100 is equal to 1 minus 0.9085. And I'm going to find this answer, 1 minus a and s on the calculator. We get 0.0914 and so on is equal to r over 100. And now I'm going to multiply by 100. And this will give me 9.14397 and so on. And so the rate of the annual depreciation rate rounded to 3 significant figures will be 9.14%. This is the final answer. Okay, let's take a look at question 5. An antique vase is now worth 2,420. So now worth, this is the current price of the vase. This happened after appreciating at a rate of 5% per year for 4 years. So n is equal to 4 and r is equal to 5. What was the original value of the vase? So we want to know the original. So we're going to go ahead and write the rule. C is equal to original multiplied by 1. And we're using a plus here because this is appreciation to the power of n. So 2,420 is equal to the original, which is unknown, multiplied by 1 plus 5 over 100 to the power of 4. And we evaluate this by firstly plugging in this entire expression on our calculator. And this will give us, let's see, original. Okay, so this entire expression gives you like 1.215 and a bunch of more decimals. Keep it accurate on your calculator. And we have 2,420 right here. So to find the original, we're going to divide through by 1.215 by 1.215. So 2,420 divided by 1.215. And we get the original is equal to 1,990.93. Now we're going to round this to 3 significant figures. It will be 1,990. That's it. This is the final answer. I hope this was clear. Okay, so moving on. Right. A painting appreciated by $1,500 over 3 years at a rate of 6% per year. Find firstly the original value of the painting, and B is asking for the final value. So we've dealt with such an example in the examples. Okay, so now what do we know? We know that n is equal to 3. This is us solving for part A right now. So n is equal to 3 and r is equal to 6. Now, we don't know the original or the final value, but we do know that the painting appreciated by 1,500. Okay? So we're going to go ahead and write the rule, which is current is equal to the original multiplied by 1 plus r over 100 to the power of n, and substitute what we know for now. So 1 plus 3. Oh, this is not 3, this is 6 right here. Sorry. Over 100 to the power of 3. Okay? Now, here's the thing. So, obviously, again, you can't solve for two variables in the same equation at the same time. So, you need to figure out a way to make one of them like the other. So here's the thing. So we know that the painting appreciated by 1,500. So I need to use this information. So if I know that it appreciated by 1,500, then I should be able to know that if the original price was X, then the current price will be X plus 1,500. Okay? So it will be this plus, and X is basically the original, right? So the current price will be the original one plus 1,500. So I can replace current right here with O plus 1,500. Okay? Is equal to the original right here. And I'm gonna go ahead and just plug this part on the calculator. 1 plus 6 over 100 to the power of 3. It gives us 1.1910 and a bunch of more decimals. So now what I'm going to do is subtract O from both sides. So the 1,500 is equal to, I'm going to rewrite this by putting the constant on the left-hand side minus original. And obviously we can subtract those. So I'm going to go ahead in the calculator and we have our 1.191016 and subtracted, we're going to put minus 1 and we get 0.191016 O is equal to 1,500. And then we're going to divide by this. And I don't know why I wrote it for you. You don't need to write the whole thing. You can just write the first few numbers. As long as you use the accurate version on your calculator, you're good to go. So 1,500 divided by it, and we get that the original value of the painting is 7,852.74532, whatever. So I'm going to round this to 3 significant figures. The 3 significant figures, this would be 7,850. All right. Now, as for the final price, which is part B, now the final value of the painting is going to be the original plus 1,500, which is the value that the original appreciated by. So now, obviously, like I've said before, we're going to use the accurate one for the original. So it's going to be 7,852.745 plus 1,500. So the final price is going to be 9,352.7. I'm gonna round this to three significant figures. So this is 9,350. This is the final price. Okay, next question. A machine is currently worth $12,000. It depreciates by 8% each year. How many years will it take for the machine's value to drop below $7,000? Okay. So you need to be careful here. This right here, this is not the current value. This is the value right now, okay? But what we're aiming for is over the years that we want the new value to become below 7,000. Okay, so this right here is the value we're dealing with right now. This is the original value, okay? So the original is 12,000. And R is 8. And we don't know N, but we know that we want to achieve below $7,000, and this will be the current basically. So minus 8 over 100, sorry, let's just write the rule first. So R over 100 power of N. And so 7,000 is equal to 12,000 multiplied by 1 minus 8 over 100 to the power of N. We're going to solve this by trial and error. All right, so we're going to go ahead and try N is equal to 1 at first and see if the value of the machine drops below 7,000 for N is equal to 1. So when N is equal to 1, the value will be 11,040. Okay. I'm going to try N is equal to 3, taking a double step. So when N is equal to 3, the value is 9,344. So I'm going to try N is equal to 4. N is equal to 4 will give you 8,000. So we're going to try N is equal to 5. It gives you 7,900. N is equal to 6. When N is 6, we get 7,276. I'm yet to drop below 7,000, so let's try 7. And the answer is 7, basically. When N is equal to 7, the value of the machine will be 6,694. So at N is equal to 7, we have dropped below 7,000. So it would take 7 years. That's it. Okay, so moving on to the final exercise. A car's value depreciated by $5,000. So this is the amount of depreciation over 5 years. This is N right here. And at a constant annual depreciation rate of 10%. So this is R is equal to 10. What is the original and the final price of the car after 5 years? So we've dealt with such an application multiple times. We're going to go ahead and write what we do know. So we know that R is equal to 10 and that N is equal to 5. Okay. And now we're going to write out the rule. The current is equal to the original multiplied by 1 minus R over 100 to the power of N. And current is equal to original multiplied by 1 minus, we know that R is 10 over 100 to the power of 5. All right. Now, so here's the thing. So again, we can't solve this because we have two unknowns in the same equation. But since I know how much the value depreciated by, I can express one of them as either. So here's the thing. So if I know that it depreciated by 5,000, then if this is the original price, this should be the original price minus 5,000 because it depreciated by the 5,000. So the current price is always the original minus the depreciated amount or plus the appreciated amount if you're dealing with appreciated. So now I'm going to go ahead and actually evaluate this expression on the calculator, and you're going to get 0.5 9049. Okay. Now, I'm going to add 5,000 to both sides. And I'm going to subtract 0.59049 multiplied by 0 from both sides. Okay, so on the right-hand side, we have just 5,000 alone. On the left-hand side, we have the original right here, minus 0.59049 original, okay? Now what I'm going to do on the left-hand side is plug on the calculator 1 minus this number right here, and we get 0.40951 is equal to, oh, I forgot original, is equal to 5,000. By the way, if you're concerned that you might accidentally think that this right here is a 0, you can just replace the original by x, no problem with that. You can just change all of those to x's, right? So you can do that if it makes you feel better. All right. So now we're going to find the original amount by dividing through with 0.40951. So 5,000 divided by that, and we get 12,209.7. Okay. So this is the original. Okay. This right here is the original. The final will be the original accurate minus 5,000. Okay, because the final will be the original price minus how much it depreciated. So minus 5,000, and so we get 7,209.7. Now let's write both correct to 3 significant figures. So the original is 12,200, correct to 3 significant, and the final price is 7,210. Okay, this is also correct to 3 significant, okay? Because this is the third significant right here, and we have a 9, so this will get rounded up to 1, and this becomes 0. Okay? That's it for appreciation and depreciation. I hope it was clear, and thank you for watching.